Hi, today I want to talk about partial fraction decomposition. This is also a technique to to evaluate integrals. So let's say we have a question like this. So this is our integral. So x to the power of 4 minus to the x minus x squared, and then we have take the inverse of this function. So let's rewrite this function here. So we can bring factor out the x squared, and then we have x squared minus 1. And x squared minus 1 is basically x plus 1 multiplied by x minus 1. So this is the basic form factorization of our original function. However, this is also complicated to evaluate, so we need to rewrite this as well. So that's the now we are going to use this partial fraction decomposition. So basically, we are going to rewrite this into 4 terms. So this is just something you need to memorize it. So we have a x squared here, and then x plus 1 and x minus 1. So this can be separate into a sum of 4 terms, which is at the different degree of the variables of the terms that is in the denominator here. So we have x of a b c d is just different terms. You can think of a different constant. In this case, in our examples, so a over x and b over x squared, since the highest power for x is x squared, so you need x and x squared in the denominator to get something like x squared, and plus x plus c over x plus 1, and then d over x minus 1. So you need at least 4 terms, and then each of them in the degree in the form of the variables in your denominator to get at least something like to get your original denominator. So, but now the problem is that we need to find what's a, b, c, d respectively to that with this sum to get our original function here. So let's so now we need to find out what these A, B, C, D stands for. So since since the left hand side should be equal to the right hand side, so now let's multiply by x plus 1 on both hands. So okay, so now let's think about let's consider this as your left hand side and this as your right hand side. So let's multiply x plus 1 on both sides. So you have x plus 1 over x multiplied by a, and then x plus 1 over x squared multiplied by b. And for the third terms here, you cancel out the denominator, so you left with only c here. And then for the fourth term, you have x plus 1 over x minus 1 multiplied by d. And also for your right hand side, since you are multiplying x plus 1, so you only so your denominator is only x squared multiplied by x minus 1. So now let's plug in x equal to negative 1. So this term becomes 0. This term becomes 0. This term is only c, and this term is also 0. And then also plug in x equal to minus 1 into this part, you will get negative 1 over 2. So now you can tell right away that c is equal to 1 over 2, negative 1 over 2. Okay, so now we have the solution for c, and now let's work for the rest of the terms, for the rest of the numerators here. So now let's work on so now let's also multiply by x squared on both hand side. So here the first term you get a multiplied by x. The second term is just b, and then the third term is x squared. So basically here, x squared divided by x squared over x plus 1 multiplied by c, and then x squared over x minus 1 multiplied by d. And then on your right hand side, it's just 1 over x plus 1 multiplied by x minus 1. So now we multiply x squared to both sides. And now let's plug in x equal to 0. And then this term becomes 0. This term is still b. This term becomes 0, and this term becomes 0 too. And over here you get negative 1. So now your solution. So now you have b equal to negative 1. So by doing this partial fraction decomposition, and then multiply by each term, each of the denominator to both sides, and then you can to solve for the numerator sequentially. So after multiplying and then plug in the values to solve for a, b, c, d, and now you can rewrite your original question into the form of a sum of 4 terms here, and it happens that one of the numerator is 0, so that's why you only get 3 terms after you rewrite your original function. So now this term can be easy to evaluate. Basically, integral of of a sum is just the sum of the 3 integrals here. So that negative 1 over x squared is just x over x 1 over x. And then for the integral of this part, it just you bring the 1 over 2 negative 1 over 2 outside, and then 1 over x plus 1 is just a log of x plus 1, but you need to give the absolute value since log cannot take negative value. And then the same formulas here. The integrals here, you can either it just memorize the formula here. So 1 over x plus 1 is just 1 over x. It just the integral of 1 over x is just log of x. So in this term, it's just 1 over x plus 1. It's just log of x plus 1. And then this will be your solution. So this is the solution of your original function. And then you can make it, you can simplify it by drag out 1 over 2 and then rewrite this into x plus actually, yeah, this one should be x minus 1 and then my x minus 1 minus the log of x plus 1, so that you can based on the log rules, it is just x minus 1 over 1 x plus 1, and then bring back the 1 over 2 into the power of the log, so that becomes a square root. So this is the simplest or it's another form of your solution to your original function. But the core or the key parts here is to use is this partial fraction decomposition to decompose your original function, where you have a complex denominator here into the unique simplest form of x to decompose your original function. So you have 3 terms here, and then for your x squared, just x plus x squared, and then plus x plus 1, and then x minus 1. So a sum of these 4 terms will give you can give you a multiplication of this denominator, and then you solve the a, b, c, d sequentially by multiplying the terms in the denominator and then plug in values, and then you can find your you can rewrite your original function here. So this is partial fraction decomposition. So thank you very much for watching the video, and let me know if you have any question.